Then we will dive into the 5 pillars framework for AWS Gen AI security to understand the core principles. We will examine AWS Bedrock's built-in security features, particularly the guard-trace system. And the highlight will be our live demonstration showing how to transform an insecure application into a protected one. Finally, we will discuss implementation best practices and your next steps. By the end, you will have a practical understanding on how to secure your own Gen AI applications. And in February this year, Andrei Karpathy coined the term vibe coding. We have been hearing that a lot. And this describes how developers now build applications by simply talking to LLMs, accepting all suggestions, and letting code grow beyond their comprehension. While this works for weekend projects, production AI systems need robust security controls. Gen AI is powerful, but comes with unique risks. Today we will discuss how AWS helps manage these risks while maintaining the benefits of this technology. AWS operates on a shared responsibility model for AI security, actually for all their products. AWS provides secure infrastructure, tools, and foundation models, while customers are responsible for how they implement these tools, what data they use, and ensuring ethical use. This partnership approach means that you're not alone in securing your AI systems, but you must understand your specific responsibilities. Let's look at what this means for your application. Trust must be the foundation of any AI system. AWS implements a zero data retention policy with model vendors. This means that your data stays within your trusted boundary. AWS provides PII protection mechanisms that can be configured and enhanced to prevent personally identifiable information from being exposed to model vendors. You can customize these protections to match your specific security requirements. These capabilities help maintain customer trust while allowing AI systems to function effectively. AWS Bedrock provides built-in security through its architecture. Models run in isolated accounts separate from customer data. Bedrock doesn't store prompts or completions by default, and it doesn't use customer data for its training. The service maintains key compliance certifications, including HIPAA, GDPR, and SOC, making it suitable for regulated industries. This architecture gives you security advantages from day one. At Tech, we have developed this 5-pillar framework for Gen AI security. This is inspired by the AWS well-architected framework and industry best practices. This is not an official AWS framework, but our approach to comprehensive security. Trust and governance establish the foundation. Data protection ensures information remains secure throughout its life cycle. Security architecture creates defense in depth. Threat detection identifies issues before they can cause harm. An incident response prepares you for when things go wrong. We will explore each of these pillars and how they work together to create a comprehensive security approach. And we can talk now about Pillar 1, Trust and Governance. For trust and governance, start with practical implementation steps. Create specific IAM roles that control who can access which models in Bedrock. Document clear AI usage policies that define acceptable use cases and ethical boundaries. Implement version tracking for your AI applications to know which model versions are in production. Enable comprehensive audit logging through CloudTrail to record every interaction with Bedrock. These concrete steps create accountability and transparency in your Gen AI systems. Data protection leverages Bedrock's built-in capabilities. All data is encrypted in transit using TLS and at rest using AWS KMS with customer-managed keys. Bedrock guardrails provide native PII detection and filtering without requiring separate service like Comprehend. Before you have to resort to using these services to detect certain kinds of information. Now this is inside Bedrock. Configure these guardrails to automatically identify and mask sensitive information in both prompts and responses. For custom fine-tuning, use S3 bucket policies to strictly limit who can access your training data. These controls ensures sensitive information remains protected throughout the AI interaction lifecycle. For secure architecture, start with AWS account separation. Create a dedicated account for your Bedrock resources with strictly limited access. Use AWS Private Link to create interface VPC endpoints for Bedrock services, including Bedrock, Bedrock Runtime, Bedrock Agent, and Bedrock Agent Runtime. This keeps all private traffic private without requiring internet gateways or NAT devices. Create custom endpoints policies that explicitly allow only the specific Bedrock actions your application needs, like invoke model, for example. For enterprise deployments, implement service control policies at the organization level to enforce consistent security controls. These architectural choices create a private, controlled environment for your workloads. For threat detection, focus on preventing and identifying prompt injection attacks. First, enable Bedrock guardrails with prompt attack protection to filter malicious inputs before they reach models. Implement rigorous input validation in your application code to sanitize all user inputs before passing them to Bedrock. For agents, enable the default pre-processing prompt that uses foundation models to determine if user input is safe. Update your system prompts to clearly define what your AI can and cannot do. Set up CloudWatch to monitor for unusual patterns like high-frequency API calls or repeated guardrail blocks. These layered protections follow AWS shared responsibility model. While AWS secures the infrastructure, you must secure your application-level interactions. Incident response follows the AWS shared responsibility model as well. AWS handles incidents related to the Bedrock service itself, while you are responsible for your applications and configurations. Enable Amazon Guard Duty to detect suspicious activities like unusual API calls or potentially unauthorized deployments. Guard Duty can identify concerning behaviors such as removing Bedrock guardrails or changing S3 buckets for model training data. Establish security baselines for your Bedrock applications to help detect deviations. Review the AWS Security Incident Response Guide and Security Perspective of the AWS Cloud Adoption Framework to develop your response strategy. We can share those links after this meeting. These practices help you identify suspicious activity before it escalates into a major incident. Bedrock guardrails address multiple security pillars simultaneously. They support trust and governance pillar 1 by enforcing content policies and topic boundaries. They handle data protection, pillar 2, by filtering sensitive information. And they are crucial for threat detection, pillar 4, by preventing prompt injection attacks. Guardrails provide a unified control point for these security concerns, simplifying implementation while maintaining comprehensive protection. Our demo today will focus specifically on implementing and testing Bedrock guardrails. We will show how to create and configure guardrails in the AWS console, focusing on harmful content filtering and PII protection. Then we will test these controls with sample inputs to demonstrate how effective they are. We will start with a basic Bedrock implementation that lacks security controls. And this represents what many Vive coding projects might look like. Then we will test that using some inputs in the prompts containing uh, content that won't be filtered and can contain PII. You will see how the model responds without guardrails in place, highlighting gaps in trust and governance, data protection, and threat detection. This establishes our baseline for improvement and demonstrates why security controls are necessary for production applications. Okay, so let me share my screen with my console. Okay. Can you confirm if you see it?
Yes, we can see it.
Thank you. Okay, here I am in my demo account for AWS. We can go into here. I'm using PowerShell. We will be running some scripts that will be connecting to the services inside this same account. For instance, I have an implementation for that will be connecting to Bedrock in this insecure way, without any type of prevention measures. Let me run it. This is just a script that is using the CLI and sending commands through the API. Okay, and you see this menu. That only asks for some information regarding a phishing email to see how the model responds. As you can see, the model responds with all the information regarding how to create this kind of email without any filtering. There are no guardrails to prevent potentially harmful content, and all the details for the phishing emails are provided. There is also no monitoring or logging of what is happening here. Okay, but if we can go to the Bedrock service and create a guardrail, we can change the behavior of our app. So for this, my connection is a little bit slow today. Okay. Here, amongst many things that you can configure in Bedrock, you can configure guardrails. I have already created the one that we are going to use today, but I will show you how to create a new one. Here you enter name, like this rail. You describe what kind of thing this is going to be useful for, what is going to block basically, and what is the message that the user is going to receive, or what after entering a prompt, instead of getting a response from the model, this is going to take the information before and send you a response back. Here's where you configure it. You can define which categories you want to block and in which level: hate, insults, sexual violence, misconduct. This works for text and also for images. a nice feature that you have here is the prompt attacks. If you remember some months ago when ChatGPT was growing, it was very common for people to share specific prompts that you could enter to bypass how the chat was programmed. Basically, saying to ignore everything that was programmed before and to reveal some information or to behave in some other way. This kind of prompt attacks can be prevented using these controls here. Also, it has a threshold of how rigorous do you want this filter to be. For topics, you can also define general topics or in detail of what you want to block. For this demo, we're going to put something like cats. It's something that the model shouldn't block normally, but as we will have it configured, this is going to be detecting anything related to cats and it's going to block that message. You can define that here. You put the name and you make a definition with all the information that you want, with as much detail as you want or you can, and also add sample phrases so this can be detected at any level if there is any relationship with this topic. You can also include more word filters for profanity or custom words and phrases, and personal identifying information. And there's a bunch of personal identifying information that you can define here for the model to block or to mask. For instance, general name, username, password, whatever that the user can enter in the prompt or could get in the response. And there have also been in the past some occurrences where you ask something to the model, and because in its training information they have some kind of information that could be personal information, it will give you that response including that. If you have this kind of filters here, it will filter in both cases if the people is entering this information in the prompt or if the model is wanting to tell you that information, this is going to catch it and block it or mask it. Okay, for more control, you can also put reject patterns for any kind of combination of words or digits that you want to be considered for these filters. You also have these grounding and relevance controls. This grounding validates if the model responses are grounded factually correct with the information that you provided in the source that you gave as a reference. And the relevance, if you enable this check, okay, we will verify if the responses are relevant to the query, and it would prevent the cases where you are getting some answer that is not related to what you ask. Okay, as I said before, I had already configured a guardrail that basically is blocking personal identifying information and is blocking the subject of the topic of cats. So let's run a script where we can see those configurations. Okay. Uh, Just to remember what was the behavior. For instance, this is for the insecure implementation. If we send some personal identifying information, the model is not going to notice it and is going to replicate it without any problems. For instance, I'm sending this prompt to the model and sending a name together with a credit card and with an email and asking the model to summarize it. And the model is okay. Yeah, it's summarizing it, sending back the credit card information and the email without any problems. We will ask something about cats. I'm asking the model to tell me everything he knows about cats. Okay, and then you have all the information. Let's try now a similar script, but this one will be using the guardrails that we have configured. Okay. We will now send the same prompt, sending the information of the credit card and the email. Let's see what happens. Okay, he says that the guardrail has intervened, that it detected that this information was being sent, and in the summary, okay, it gives an answer to the request for a summary, but here is masking the information, both of the credit card and the email. Let's try asking about dogs. This I will tell me. This shouldn't be blocked at all because there isn't any guardrail that is preventing this information. Okay, here you have information about dogs. Let's go and ask about cats. Here, the guardrail also intervened and gives a reason and detected the message that had information that had to be blocked because it was relating to a topic, cats or related animals. So the information is not shown. Okay, so basically this shows how this guardrail acts and how this configuration, as I showed you a while ago, it can be like you can fine tune and the details and make it very custom regarding your use case. Okay. So based on what we have been showing, here are practical implementation steps. You start with bedrock guardrails as they address multiple pillars at once: trust and governance, data protection, and threat detection. Layer these with proper IAM controls to address security architecture needs. Add CloudWatch monitoring and guard duty for incident response capabilities. Finally, regularly test your security controls against new threats and iterate as needed. This is important because this is using a specific model, but you know that models evolve, they change, and the responses that you get can change a little. So it is important to iterate and to be testing all the time. This layered approach ensures comprehensive protection while maximizing the value of native AWS features. I don't know, Will, if we have some questions.
Yes, we do have some questions from the live stream. We have three questions. The first one is from Sarah, who is a financial services compliance officer. She says that we are considering using Bedrock for customer service chatbots, but we are in a heavily regulated industry. So the question is, can Bedrock guardrails be customized to enforce industry-specific compliance rule like preventing financial advice?
Okay, that's a great question. And the answer is yes. Bedrock guardrails can be customized for financial services compliance. You can create specific denied topics, as I shown with cats, but now you will say prevent talking about financial advice or investment recommendations or account management instructions. You can also define custom regex patterns to identify and block responses that might violate regulations. For your industry, I will recommend combining guardrails with regular model output auditing and maintaining detailed logs of all operations or all interactions for compliance reviews.
Perfect. Then we have a question from Miguel, who works with security. He's a security architect. He says that you mentioned that guardrails help with prompt injection, but how effective are they against sophisticated attacks that might use encoded characters or other evasion techniques?
Okay, that's an excellent point, Miguel. Guardrails provide good baseline protection, but sophisticated attackers can sometimes evade detection with techniques like Unicode character substitution or context manipulation. And for high security environments, I would recommend implementing additional application level input validation using the most recent model versions, which have improved security properties and enable advanced prompt features with pre-processing. So this will be in your app before sending this information. You can also use large language models to help you with these types of more complex filtering. Also, AWS regularly updates guardrails to address new evasion techniques. So staying current with Bedrock's updates is important.
Excellent. And the third question is from Rachel, who is a product manager. Our team is considering moving from a prototype to production. The question is, what's the performance impact of enabling all of these security features, especially guardrails? Will their response times increase significantly?
Yeah, Rachel, yeah. That's a practical concern, and I completely share it. Enabling guardrails does add some latency to requests, typically between 100 to 300 milliseconds, depending on the complexity of your guardrail configuration. It's not the same if you have one denied topics than if you have 10. Um, for most applications, this is acceptable given the security benefits. If you are concerned about performance, I would recommend starting with the most critical guardrail features first, like prompt attack prevention and PII filtering, then measuring the impact before adding more controls. You can also add client-side caching for common responses to offset this added latency that you have for frequent requests.
Okay, excellent. We don't have any more questions.
Great. So to conclude, while vibe coding might work for prototypes, production Gen AI applications need comprehensive security. Bedrock guardrails provide an excellent starting point by addressing multiple security pillars simultaneously. However, complete protection requires additional controls like IAM policies, VPC endpoints, and monitoring solutions. The resources linked here that we have discussed, we will help you implement a complete security strategy beyond what we have shown today. So thank you for joining today's session.